Okay, I'm going to try to keep this video short. This is 8.1, graphing simple rational functions. First of all, I want you to take a note that rational are functions that have fractions in them. So our parent function for rationals is f of x equals 1 over x. And you may remember that x on the bottom causes something that is not generally a function, or it's just going to look different than anything you've ever seen before. So this is what's causing it to be a rational function, is that it looks like a fraction. Okay, so to graph these, we're going to use our transformation rules. It's the same gestures that we've done before, where we kind of dance with our heads back and forth. So just remember, when things are inside, they're going to affect our x values, and we need to think opposite. So think opposite. And then when things are outside, and what I mean by inside and outside, I'm talking about inside and outside of that fraction, or that wherever the parentheses are in the problem. So things that are outside are going to affect the y value, not they, the y value, and they are what we think they are, so we're going to think the same because they're outside of the parentheses. So those are the two notes you need to take on transformation rules. The last thing you need to note, and this is kind of weird, it's something that you haven't really seen before. So what you have right here, this whole graph right here, is my parent function. Notice it kind of looks like two parabolas, but they're opening really like on a diagonal, so it looks a little bit strange. There are two reference points that we need to remember, and they are 1, 1, and -1, -1. And here's the word that you've never heard before. All right, this word is going to be asymptote. All right, that's got a whole lot of letters before we hit any vowels. So it's an asymptote. Asymptotes are secret lines that we don't normally draw, and they are where it looks like the curve is going to get close to them forever, but it's never going to touch. All right, so write down that definition. An asymptote is where the line is going to get close to, but it's never going to touch. Think about it like an imaginary fence for a dog, right? Like you don't see it around the yard, but the dog can get really, really close to it, but if they touch it, that's a problem. So we don't ever want to touch. So we've got two asymptotes for our parent function. One of them is right here, and this is the y equals 0 line. Remember, y equals lines kind of run left to right. And then I've got this other asymptote, and I did not draw that very well. I've got this other asymptote that's running up and down, and that is our x equals 0 line. So all of these things that you just took a note of about the asymptotes and our two reference points, those are all things that you need to have drawn on your notes for your parent function. And again, that parent function is f of x equals 1 over x. Okay, so let's look at how to apply these transformations and change our graph. So the first thing I want us to do is think about what all is happening to our x values. So remember, x values are on the inside, so I'm just looking inside my parentheses right here. I've got a +1 on the bottom, which you all know means I need to think opposite, so that's going to make me move left 1, and left is like subtraction. So when I work out the x values, I'm going to, I'll make a little note here that we need to be subtracting. Okay, that's everything that's happening to the x. So now we're going to look at our y values. Oh, and we do need to make this note also. This x value is also an asymptote. So that means my new asymptote is now at x equals -1. All right, my y values, there's a few things that are happening on the outside of the parentheses. First of all, the negative at the front is going to cause a reflection. So we're going to reflect. Then the 3 at the front is we want to think the same, so 3 is going to make it bigger. So that is going to be a stretch. And we're thinking in the y direction, so that's going to be vertical. Vertical stretch by 3. Just know that when we stretch, that's, I said times bigger, so this is multiply. And then the minus 3 at the end is going to move us down 3 because we're thinking in the y direction. The last little thing that we need to note is that for my y value, my new asymptote is the direction that I'm moving, which is -3, so y is -3 is going to be my new asymptote. All right, rewatch that if you need to make sense of before I move on. Okay, so now we need to do our reference points. We're going to use the 2 reference points, the same 2 every time. So we're going to do -1, -1. They will always give those to you, but like I said, they'll be the same every time. And I'm going to try writing this a different way just to see if this makes sense to you. So we said for our x values, we want to subtract 1. So for my x value, they give me the x value as -1, but I want to subtract 1 from that. So my first x value is going to be -2. For my y value, it starts as -1, right? I'm talking about from this ordered pair, it started as -1. But there's a few things I want to do to it. I need to reflect and stretch. And those are both multiplication. So I need to take my -1 value and multiply it by -3. And then I want to move down 3, which I forgot to write, but that is going to happen by subtracting 3. So if I work that out, that's 3 minus 3, I get 0, which means this new point is now at -2, 0. Okay, I'm going to switch colors for us so we can follow again. Now I'm going to do the same thing with 1. So for my x value, I was supposed to subtract 1, which means this x value is now 0. For my y value, I'm supposed to multiply by -3 and subtract 3. That gives me -3 minus 3. So my new y value is -6, which is going to give me this new point, 0, -6. Okay, so let's try to take all of that and put it on the graph. So we're going to start with our reference points, and I'm going to color code for us. So my first reference point is -2, 0, so I'm plotting that, -2, 0. My next reference point is 0, -6. All right, and now we need to go back and plot the 2 asymptotes that we labeled at the very beginning. So my asymptotes are at x equals -1. All right, that's going to look just like this. I'm hitting the x-axis at -1, and then y equals -3. And that's going to go this direction. And so that might be a little bit hard for you to see, but just realize that I'm supposed to have curved lines that have to stay in those boundaries that I drew. So I'm going to have like weird little parabolas that stay in these boundaries. So there's one of them, and here's my other one in green up here. So the green and the purple together, if you look there, the green and the purple together make your final graph. So that might be a lot of color going on, but everything that's on here is what you need on your graph. All right, so that was a lot. So we're only going to do one example. We'll start with one in class together tomorrow. And I just rewatched and actually found one little mistake on this slide. Nothing is wrong with the work that we worked out, but I misplotted this green point. I accidentally went -2, -1. So this point right here, I just need to move up. Just notice that I misplotted that in case you were confused. Okay, so we're going to do one last example where we have to write the equation, and they're giving us a format to start from, so really know that all we need to fill in are my A, my H, and my K. And I'm going to sketch for us just a little reminder. My original problem graph looks like this, where I've got my normal asymptotes, and these are at -1, -1, -1, and 1, 1. So just keep that in mind. Okay, so this is not going to be as hard, and hopefully this kind of makes some sense to you. The first place to start is my asymptotes. This is crossing the y-axis at 1. And remember, y is outside, which means my k value is going to be 1. This other asymptote is crossing the x-axis at -2, but we want to think opposite. So remember, on the inside there, that's going to need to be a +2. Okay, so the last thing we need to do is thinking about if there's any stretches or compressions. Now, normally this point would only be 1 away from each of those asymptotes, but now if you count in the y direction, we are now 4 times away, which means this outside number should be a 4. All right, it's going to happen the same in the other direction. Instead of being 1 away, I'm now 1, 2, 3, 4 spots away from the asymptote in the y direction. The last piece to check is just to think about the direction that this is opening. So normally it's going to open, right, pay attention to this parent function up here. Normally you're opening like up and to the right, down and to the left. Here I'm opening on opposite sides, which means there's been a reflection. So this shows us that we have a reflection, which should tell you that something in the very front should be negative. So if we put all of that together to write our new function is g of x equals -4, 1 over x. Remember that was positive 2 because we have to think opposite, and then plus 1. And there you go. There's your function. So that's all we have for today. Tomorrow we will kind of pull all this together and do some more problems together so that you're ready for your test.